Okay, so in this video we'll discuss this problem from the model question paper, but this is about Lagrange's theorem. So according to Lagrange's theorem, the order of a subgroup divides the order of the group, which means uh, if like in this question we have a group whose order is 660. This means there are 660 elements in that group, right? And then it says order of K, which is a subgroup of G, is 66, which means there are 66 elements. And then we are asked to find the order of another subgroup H, right? So it's also given that K is a subset of H is a subset of G. So it's a proper subset because there is no equal there, which means the number of elements in H should be less than G and it should be greater than K, right? So, according to Lagrange's theorem, the order of a subgroup should divide the order of the group. Now, if you consider G, its order is 660, and the order of the subgroup K is 66. So that satisfies Lagrange's theorem because 66 divides 660, right? So 66 times 10 is 660. So one way to state Lagrange's theorem is like the order of a subgroup divides the order of the group, or the other way to say that same thing is uh, the order of a group is a multiple of the order of a subgroup, right? So here the order of K is the group is a multiple of the order of the subgroup K, which is 66 times 10. Now, since H is a subset, I mean K is a subset of H. Uh, like if you consider H as a group, then K is a subgroup of H, right? So the order of H should be a multiple of the order of K as well. So right. So again, right. This is very right. This is 66 times 2 times 5 is equal to 660, right? So the order of H cannot be 660 because it's less than that, right? But it should be a multiple of 6 also. So the only possible multiples in this case are like I can 66. It should be a multiple of 66. So I can have 66 times 2, right? So 66 times 2, which is 132, right? And then the other multiple I can find is 66 times 5, right? 66 times 5, which is 330. So let me just check if that's the 66 times 5 is 330. Okay, so these are the only possible multiples of 66 which can divide 660 as well, and so those are the possible values of the uh, h. So that's one way to solve that, and then there's another way where you can just list down all the factors of 660 and multiples of 666 and choose the ones only that divides 660. So that method will be like this. You first do, it cannot be 66 times 1, right? Because it cannot be equal to 66. So 66 times 2 is 132. Then you list down the next one, which is 66 times 3, which is 198. And then you have 66 times 4, which is, I think, 66 times 4 is 264, and you have 66 times 5, which is 330. So now we don't have to check 66 times 6 and all the way up to 66 times 10 because this is halfway mark. So you definitely know any number greater than that it's not going to divide 660. So you have to select only those which divide 660. So 132 divides, 330 divides, but 192 and 264 cannot divide 660. So those two cannot be the answer. So Either of these methods will give you the answer as 132 and 320.